right, here we go. Trigonometric ratios. Let's go cover some definitions. Trigonometry. This is the study of angles. I'm using the symbol and sides of triangles. Okay, the study of angles and sides of triangles. This one in particular, we're going to focus on just the right triangle. So we just finished doing the right triangle before y'all left for break. We did what with the right triangle? Two things. Measure right and Pythagorean theorem. Okay, so we did those two things. All right, trigonometric ratio. Okay, this is a ratio or fraction because those mean the same thing, right? Ratio and fraction. And we're going to work with the fractions. Like I said, it means the exact same thing. Most of y'all like to hear it, I guess, in fraction. A ratio or a fraction of the size of the triangle. Okay, so ratio of the or fraction of the size of the triangle. And when I say size, I mean like side lengths. All right, the three basic trig ratios are sine, cosine, and tangent. Sine, cosine, and tangent. Now you'll be writing the abbreviation for these. Okay, so here's the abbreviation. Sine like that, S-I-N. Cosine, C-O-S. You can see them on your calculator. They're like just 3 letters. And then tangent is just T-A-N. So we'll write just the abbreviation for those. Okay, some terminology that you have to know. Okay. On the right triangle. This one you already know. Okay, this one we call a hypotenuse. So label it the hypotenuse. Okay, that one's always going to be known as the hypotenuse. Now, when we're working with certain angles, so let's just say we're working with angle B. So everybody put a star at angle B. Okay, maybe highlight it like that. Okay, so working with angle B, that is known as the hypotenuse. This side down here is known as the adjacent side. So everybody write adjacent. Adjacent because it's right next to that angle. This side over here is way over here on the opposite side. So we're going to call this side opposite. Okay, so that's the opposite side. This is the adjacent side. That's the hypotenuse for this particular angle. Now, over here, let's say we're talking about angle A this time. So everybody put a star at angle A. Okay, highlighted it. Something. Okay. What's AE going to be called? Side AE, what's that one called? Hypotenuse, just like I said over here. It's always going to be the hypotenuse. Everybody write hypotenuse again. And that's always your hypotenuse. What side AC going to be called? Adjacent, very good. And then side AC? Opposite. So see how it changed just a little bit? Okay, depending on which angle you're working with. Okay, because you're going to work with either angle sometimes. Okay, just one of them, but it depends on which one you pick. Okay, but so you just got to know opposite is going to be way on the other side. Now sometimes some people confuse themselves because when they start twisting and turning this right triangle, they accidentally label the hypotenuse as adjacent because it is kind of, by definition, it's right next to it, right? But you have to label that as the adjacent side. It's always the hypotenuse. All right, what I already have printed out for you are the trig ratios. Okay, these right here. Trig ratios are formulas that were derived by some mathematician. Okay, and it helps you solve for sides. Okay, all you have to have is one side and one angle. Okay, kind of like the special rights, except the special rights, they were always 30, 60, or 45. These could be any type of angle. All right, so here's these formulas. Good news is you don't have to memorize them. A few years back they did. Okay. All right, so for cosine, okay, of angle A, that ratio is the adjacent side over the hypotenuse. Okay, we're going to practice writing these ratios in a second. Okay, so just kind of pay attention. For the sine of angle A, this is the opposite side over the hypotenuse. And for the tangent, it's the opposite side over the adjacent. Okay, so when you say adjacent to hypotenuse, there's going to be a side over there, or maybe a variable. And so you have to remember how to use this formula. Okay, because they're going to always, if you always know the formula, you'll just have to know how to use it. Some people, back when we had to make these, make y'all memorize it, we use this acronym. So, TOA. Anybody heard of that before? The TOA? Okay. This is just a quick little acronym that kind of helps them memorize it. Okay. Again, you don't have to memorize it even after the fact. I would say, like last year, students, even though they don't have to memorize it, they like writing that at the top of their paper just because it was a quick reference. Rather than having to go back to your formula chart. So you'll probably want to write that at the top of your paper. But here's how it goes. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Okay? So SOHCAHTOA, you can write that at the top of your paper. Alright, so keep those formulas right there because we're going to write these ratios out. And so look, here's A. So let's start off with A. The ones on the far left. Sine of A, which one's that? How does sine go? Opposite over hypotenuse. So what's the opposite side of A? Little a, right? What's the opposite? What's the hypotenuse? C. So the way you write this ratio out is little a over little c. That's how you write out that formula. Sine of capital A is little a over little c. Let's go to cosine now. Cosine is what? Adjacent over hypotenuse. So what's the adjacent to angle A? B. So B goes on top. And hypotenuse is C. So that one's B over C. Tangent. I think there's a typo on y'all. Y'all say sine? Or does y'all say tangent? Oh. Alright, so tangent of A is opposite over adjacent. So what's that one going to be? A over B. Very good. Okay, so that's the way some problems are going to look on your assignment. I'm going to give you a sign of some particular angle, and you have to tell me that ratio. Okay? All right, sine of B. Okay, so now I'll use green now. So that's the same over here. What's sine of B going to be? First, you have to go back and think of the formula.
Little b over c.
Very good. Little b over c. Opposite over hypotenuse. Okay, and if you want to, guys, if you want to write this out first, put O over H. What's cosine? A over H. All right? Now what's tangent? O over A. Okay, so if you want to write those letters first, then write ratio you can. All right, what's cosine of B? A over C. Little a. And then the last one, what's tangent of B? Little b over. That's it. Okay, so that's using a formula. You wrote out the formula, just writing the ratios. Okay, let's do it one more time. Okay, getting repetitive so that way you can figure out how to write these things out. Now they have numbers. Okay, so sine of x. Let's focus on x first. X is down here. Okay. How does sine go again, by the way? O over H. So, what's this ratio going to be here? What's opposite of angle x? 12 over? You don't know it, but can you figure it out on previous knowledge? get that?
That comes from
Attaboy. 12 squared plus y squared equals c squared. Remember that? Square root. It's 13. By the way, that's a triple too. Alright, so 12 over what, guys? 13. Good. Cosine, how does that one go? A over h. And so it's kind of good to write a little formula off to the side. What's that ratio going to be? 5 over 13. Good. And tangent of x. Opposite over adjacent. So see, it's getting it right. Negative 12 over 5. There you go. Alright. And you always want to kind of double check to see if you can reduce them. These are all there. That's crazy. 13. So, there we go. Alright, let's go to the next one. Y. So now you want to focus on this angle up here. Okay? So, Matthew Morse, tell me what sine of y is. Sine of y. Good. Over. Good. 5 over 13. Hey, Brown, what's cosine of y? 12 over 13. Just go back and look at the little formula. Right? And the last one, Trent. Just a Trent. What's tangent of y?
5.
Very good. Over. Good. Opposite over adjacent. Good. Okay. So we wrote out the formula 12 times. Okay. That's what you got to do to solve this problem. Okay. So write it down for you. Okay. Now it's calculator time. Okay. Because we're going to use the calculator. Let me use my cosine test. So get your calculator ready. Now, to get it ready, what you need to do is you need to go to mode. Okay? You need to go to mode because I'll give you all a new calculator number. This stuff, just I'll give you one for now. Okay, I'm not going to give this stuff for now. Okay, everybody's got to go to mode because it has to be in degrees. Okay, now it might already be in degrees because my last class was used doing trig also. Okay, everybody know where mode is? It's next to second, top left area. And then it's the third line down. It says either radian or it says degree. Okay? And you want degree to be highlighted. So you gotta like move the cursor over and hit enter. Okay, so make sure that degree is highlighted. Everybody with me? Yep. Alright, so make sure you write this down. I've had students in the past do the whole homework assignment not in degree mode, and so they get it all wrong. Okay? So make sure you have it in degree mode. Okay, so let's practice this. What is this here? Round to 4 decimal places. So this function is sine 42. Sine 42. What do you get? Point what? Point something, right? 6 what? 1, 3. So the 3 does not round the left. Okay, so we're going to round to 4. Okay? Let's do cosine of 15. Yeah. Cosine of 15. On the left. 9, 6, 9. What was the 6? That's like this position, 2. Okay, over here, let's start out with 67 degrees. Because I want to scratch it off. We might already did it. Sorry. And I want you to put a fraction. Let's put, I don't know, 12 over 8. That's a lot of the ones that you're going to do in a second real fraction. So you get tangent 12 divided by 8. Close parentheses, or you can see answer. What do you get? 2, 6, 2, 0. Okay, so just for you to put those in, all right? Okay, now here's how we're going to solve for the sides. The first example, we're going to solve for A and B. Notice, all they gave us was this angle measure, which is 36 degrees, and one side length. That's it. We can't do Pythagorean theorem, and we can't use special rights, which we already learned about here. All right. So, ask yourself first, which one do you want to solve for first? Take a look. A. All right. So, A first. So, we're going to solve for A first. What is the A according to the angle that they gave us? In terms of that terminology we were talking about earlier. Okay. Opposite. So I want you to put an O next to that. Opposite. Then you say to yourself, well, what did they give us? They gave us that 10. What is the 10 according to that angle? Hypotenuse. So put an H next to that. So then you say to yourself, what uses O and H? Which trig function? Sine, cosine, or tangent? So, very good. I like how you said that. So remember, it says it's easy to write this at the top of the paper. Write it down. So that we don't have to flip back to the other page. All right, so we're going to use sine. So everybody writes sine of the angle, which is 36, equals, we're going to write the ratio again, which we just wrote both times. So how does that ratio go? A over 10. Very good. Okay? This is how you set up the problem. Sine of 36 equals A over 10. Okay? Here's how you solve for it. You put this over 1, and this, I just taught this to my students class because I think it just shows the algebra. And you cross multiply. Okay? Cross multiply. What's A times 1? Just A. Then come to the equal sign. 10 times sine of 36 is some crazy number, which we are going to use our calculator for. See, we already got A by itself, so y'all punch in your calculator 10 times sine of 36. Tell me what you get. 5.8. Let's round to 3 decimals. All right, so there's A. We found one of the sides. Okay, so there's one of our answers. A equals 5.878. All right, so now we just have to solve for the B. Okay, so let's solve for the B over here. What is the B? Just like we did over here, what's the B to the angle? That one's opposite. Adjacent. So put an A next to it. Okay, we're still going to use the H over here. Now, could you use A? Sure, we already solved for it. What else could you use to solve for the B? What did you learn last year? What? Pythagorean theorem. So look, you know A, you know this, I can do Pythagorean theorem to solve for that. So, you know what, your homework, if you want to do Pythagorean theorem, you can do it. But since we learned this new thing, I want to practice using the trig again, okay? So, what are we going to use to solve for B? We're going to use those two right there. Cosine, very good. So, everybody write cosine of 36 degrees. We're still using that angle. Equals, how does the ratio go? Very good. B over what? 10. Good. All right. Cross multiply again by putting this over 1. What's B times 1? B. What's 10 times cosine of 36? Put that in your calculator. Round to 3 decimals. 0.90. And then there's your B. Okay, so we use trig functions, we use the trig formulas to solve for those sides. Okay, now what I want you to kind of get used to, because sometimes notice the variable was on top. I'm going to highlight this. Use the variables in the numerator. What did we do both times when the variables in the numerator? What's that called? We multiply. Okay, so you're going to see on this next example how the variable is in the denominator, and we're going to do something else. Okay, but so the variables in the numerator, all you do is multiply. Okay, we'll write that note down here in a second. Okay, so which one you want to solve for first? A or C? A. What is the A? Very good. So we're going to go with H. And then what is the 9? So we're going to use the whole number. The opposite. So what uses O and H? Sine. Good. So let's use sine now. So sine of 70 degrees equals what, y'all? 9 over H or A. Either one. Alright? Hey, now look. I'll highlight that for you. Notice where the variable's at now. Where's it at? To the denominator, right? So you're going to see it's going to end up being a little bit different. When it was in the numerator, what did we do up here? We multiplied, okay? But now it's in the denominator. So I'll show you how to solve for this one. Still put it over 1. Cross multiply. What's 9 times 1? 9. That equals A times sine of 70. We're just going to write it out. A times sine of 70. How do you get A by itself, y'all, algebraically? Not subtract, divide, right? So we divide by this number. That is a number, by the way. Remember when you punch it in, you get decimals? So divide by sine of 70, and that's it. And then we got it by itself. So A is going to equal whatever 9 divided by sine of 70 is. So punch that in for me. 9 divided by sine 70. 9.57. So there's A. Okay, let's practice it one more time. Let's solve for C now. What is the C according to the table? Jason, so put an A next to it. And we're going to still use the opposite side over here. What uses A and O? Tangent, very good. Everybody right. Tangent of 70 degrees equals the ratio of O. 9 over C. Very good. Pay attention because last year I had a lot of people accidentally put the C on top of the 9, and that's not how it goes. You have to follow that formula. Okay, where's the variable at, y'all? On the bottom. Okay, what did we do a second ago when the variable was on the bottom? We divided. So if you want to, you can do a little, instead of doing all of this cross multiplication, what do you think you would divide, guys? 9 divided by what? Tangent of 70. Okay, so you can remember when the variables are at the bottom in the denominators, you divide that or that. When the variables are on the top, like those two up there, what did we do? Multiply. Okay, so what's 9 divided by tangent of 70? Right, so there's the C. C is equal to that. There we go. All right, so let's write that little note down just off to the side. Okay. Variable is on top means we multiply. Okay. Something quick to remember. So that way you don't have to do cross multiplication every single time. Okay? Y'all did cross multiplication last year in algebra 1, right? Don't cross multiply. Yeah, so you don't have to do that again. Okay? What about if the variable's on the bottom? Variable bottom Okay. Sometimes they'll turn it into, you know, a word problem or like this one an area problem. How do you make area of a triangle, guys? That's it. So 3x minus 5 divided by 2. That's going to be the area. Well, what's the base in this case? 150. So it's going to be 150 times the height. What's the height? H. We don't know H, so we got to go solve for that. Divided by 2. So we need to solve for H. How are we going to solve for H? What did we just learn all today? We're going to use sine, cosine, or tangent to solve for H. So notice this right triangle right here. The right triangle. We know this angle. What else do we know? What else do we know? The adjacent? No, we don't know the adjacent. We know the hypotenuse. The hypotenuse is 100. The adjacent, by the way, goes from D to B. What is that one? Where does it go from? A to B, not D to B. So yes, last year a lot of people thought that was adjacent. Okay? But it's kind of close, but it's kind of goes from this point. Alright, and then we're solving for this one over here. What's that according to the angle, y'all? Opposite. So which one uses O and H? Sine. Look at your formulas. We're going to use sine. Sine of what? 40 equals, I'm going to write out the ratio. H over 100. Okay. Let's use what we wrote down a second ago. Where's the variable at? On top. So what do? We just multiply. What do you multiply? Just go straight to your calculator. 100 times sine of 40.
It doesn't matter which color we put it in.
It doesn't, but I do want, that's a good question. I do want to show you this under the elbow. Just mistakes that students make last year. I've had students, so he asked, does it matter what order we put it in? What were we multiplying? 10? 10 times, what was it, tangent or sine? Sine of 40? It was 100, okay, either way though. If you enter it like that, you don't have to close it. I always like to just close it because it looks a lot more formal and I know there's not going to be any mistakes. But if you don't, you'll still get the same one. Okay? That's the safe way to enter it. But then he said, well, can we put it in after? And the answer is yes. But here's what students did last year. What's wrong with that picture? You didn't close the parentheses, right? And so students did that. See how you get some weird number? You got to enter it. You can put it in after if you want, but you got to close it and hit times 100 like that. See how you get a different answer? And sometimes it won't always be so crazy like that for where if that's a red flag to you. Sometimes it'll look like a normal number, and then you get it wrong. Okay? So it's okay to enter it after. Just make sure you close the parentheses because you got to do only the degree measure next to that. Okay? All right. So. Okay. 64.2. So the height is 64.279. So we're going to plug that in right there. 64.279. Since you already have it in your calculator, why don't we just press times what? Times 150. Enter divided by 2. So what's our area of this triangle going to be? Big number. 4,000? 4,000 what?